Welcome everybody. Finally kind of getting to a unit where we're going to sort of combine some things we've already learned about whole numbers along with a few algebraic ideas. And one of those big ideas is exponents. You may have also known them to be called powers. So I've written what an exponential expression is here. It just says it's an expression or a math problem without an equal sign that is expressed using a power or an exponent. So down here I've identified some of the parts. So the exponent is actually a raised number. The base is the larger number you see written there. And the power is telling you how many times the base is multiplied by itself. So I've written what we call this expression out in what we call expanded form. So when you see 5 times 5 times 5, that's a numerical expression. But when we write it as an exponential expression, it's just 5 to the third power. You can see that exponents allow us just to be a little more brief. So if 5 times 5 times 5 equals 5 to the third, 5 is our base, 3, you could either call it your power or your exponent. And those words are just used interchangeably. So below, I have just kind of mentioned some areas where exponential expressions are really utilized. We use them to represent really large numbers, like 100,000. That's a power of 10. So since it's a power of 10, it could be expressed as 10 to the fifth power. Really tiny numbers can be expressed the same way. They involve negative exponents, which you really won't be tackling in 6th grade, but it's good to know that it is out there and it will come up in your future. Exponents are just super handy. You've already probably used a little bit of area in your previous experiences. So when we talk about area of a square that measures 1 meter on each side, we say the area of it is 1 square meter. And one way to avoid writing the word square is to use the power. So you can write meters to the second power, or you could write the phrase square meters. It would not make sense to represent a flat space like area here. This is just a flat two-dimensional figure. It would not make sense to represent three-dimensional figures with the same kind of units. So imagine that you have this, not imagine, but look at the cube, and I've got it 1 meter on all sides. Then the volume of this is expressed in cubic meters. So volume of a cube, if all the lengths were 2, would be 2 times 2 times 2. So you have 3 dimensions, which is really where the cubic comes from. So we would express our answer there. 2 times 2 times 2 is 8. So you could either write meters to the third power, which is really read cubic meters, or you could actually write the phrase cubic meters. So you can use three-dimensional, the 3D unit with really pretty just about anything, and typically we just write the abbreviation, and I gave a couple of examples here with centimeters and feet. So it's important not just to know that the power is cubed, but what it means. So I've written out cubic foot is a cube with 1 foot on each side. An additional use of exponents is to represent prefixes for the metric system. Kilo, for example, means 1,000. 10 to the third power, 10 times 10 times 10 is 1,000. So we could write 1 kilogram as either 1,000 grams or 10 to the third grams. It just gives you more options. I continue that discussion here with the prefix mega and giga, which you hear a lot in technology. Now, so down here, I just want to reiterate what some of our terminology is. So on all of these questions 1 through 5, I have written all of these are written in what we call expanded form. And I'm asking you to express them in exponential form. So the first one, 8 times 8 times 8 times 8 would be expressed as 8 to the fourth power. It is important that your exponents be raised and tinier than the base so that it's clear. So count up how many times you're multiplying 10 by itself. 1, 2, 3, 4, 5, 6. So your base is 10. How many times you're multiplying it by itself is your exponent. So it works the same way if you have something that's not a number. A times A times A, the base would be A, and you're multiplying it by itself 3 times. Same thing with a word. Meter times meter, the base is meter, and the power is 2. Same thing with centimeter. Centimeter is the base, sorry, and we're multiplying it by itself 3 times. So centimeter cubed. So we're going in the reverse order down here. Now we want you to write each in expanded form. Okay, so 2 to the fourth power. In expanded form is just 2 times 2 times 2 times 2. And that's it. That's expanded form. So 10 to the fourth is 10 times 10 times 10 times 10. That is an expanded form. Sorry, I'm going to try to make my pen a little tinier here. It's not quite so fat. Okay, so 2 to the third would be 2, and you could use the multiplication, you could use the multiplication dot there if you prefer. So times 2 times 2. So it keeps wanting to jump back to the wide pen there. So there's my expanded form. Over here, I've got 2 to the third. So I'll get that part first. 2 times 2 times 2 times another 2 to the second. So 2 times 2. That's expanded form. Now down below, it's asking you to actually evaluate. In other words, do all the multiplication to get your result. Now, you may be able to see exactly what it is, and that's fine. If not, and you need to do some steps, that's fine too. But what we're doing is we're continuing on with the work that we've just done above. So I could do the first 2 2's together and the second 2 2's to show that that would be 16. 10 times 10 would be 100. The other 2 10's is also 100. The shortcut, if you're not sure, you multiply the 1 times 1 and you count up 1, 2, 3, 4. So 1, 2, 3, 4. So 10,000. 2 times 2 times 2, that one's going to pop up a lot. If I just do the first 2 numbers at a time, I get 4. But 2 to the third power is worth remembering because it comes up often. So over here, we just figured out that 2 times 2 times 2 is 8. So there's the first, I'll just write this part again. The first 3 give us 8, and then that's 16 times 2, and that's 32. So the answers down here, these are what we say they're evaluated or simplified. Up here, we wrote, these were exponential expressions that were given, and we wrote them in expanded form. So you kind of got a little bit of terminology to get used to. Now this next part, I think, is really where it gets fun. Now we're using exponents to write the following, but we're only trying to use one power only. So for example here, when you see the problem 4 times 8, if you have to try to represent 4 times 8 using powers, you don't want to go ahead and multiply and call it 32, because that would make the problem a little harder. So I just think about, well, 4 could be written as 2 squared, and 8 could be written as 2 to the third. If I write that all out in expanded form and then multiply it together, I can see that 2 times 2 times 2 times 2 times 2 in exponential form is 2 to the fifth. And we're trying to get exponential form. Sometimes there's more than one way you can work the problem, and I'll show you that a little bit later. So let's do part B. I know 25 can be written as 5 to the second power. And when you see just a plain old 5, remember that's really like having it to the first power. So that would be 5 times 5 times 5, which is 5 to the third power. Now, you may not need this step right here, and that's fine, because some of you are already going to realize, oh, that's just going to be 3 5s. But if it helps you, to write that step, then go ahead and include it. So let's always pay close attention to the caution box. The error sometimes made is thinking that it's 6 2's instead, which makes no sense. Oh, sorry. Let me erase right here. Sorry about that. I'm not making much sense. This little caution was about this problem right here. A student will want to say, oh, well, there's 2 2's here and 3 here, and they'll see that it's a multiplication problem and think that they're supposed to multiply the exponents. But really, it only makes sense to add up the exponents. That's why this little additional step might actually be a good idea for a lot of students. Well, let's test drive it a little bit so you can see what we mean. So right here, let's get back to our pen. Probably, sorry, I don't know why it keeps doing that. So right here, this is a great example of one that you could do more than one way. The first thing that comes to my mind is that 16 is the same thing as 4 squared. So if I have 4 squared times 4 to the third, if I write it all out, it's going to take a lot of room. So I know that I've got 2 4's, then 3 4's, and then 3 more. So I've got 6. Another way you could do it is you could just add the exponents. So I'm going to just write my exponents up there, because the power right here is really a 1. It's just sort of understood. So I've got 4 to the 6th. Again, you may be able to get there without this step right here, and that's fine. This problem could also have been rewritten. Everything could have been rewritten using 2's, but that would be more challenging. So try to go with whatever's the most obvious and the easiest. So here I notice, well, I've already got a bunch of 2's, so maybe I'll just put those together first. So 2 times 2 times 2 to the third, and then I'm just going to write my 8 over here. If we go ahead and get these put together, remember we keep the base. We've got 1, 1 plus 3. So if you want to write it out like that, you could. We could replace the 8 with 2 to the third. Remember I told you that one would pop up a lot. You're going to want to remember that one. So 1 plus 1 plus 3, that's 5. So remember, our goal was to get 1 base and 1 power. So if I have 5 2's and then another 3 2's, I've got 8 2's. But again, if it helps to write that step, go ahead and write that. And if you need to write the whole thing out in expanded form, you can for now. As you progress, you'll find that that will become a little too much labor involved. All right, let's do this last one. Even though it's letters, it works the same way. I'm going to rewrite it just writing. It's the same as seeing this. So one common mistake is sometimes people think the power for B right here is 0. but that's not the case. If it's there one time, so the power is 1. So it would be b to the 1 plus 1 plus 3. So that would be b to the 5th power. And again, you could have gone directly from here to here, and I hope that you can. A problem where you would have to have some steps would be right here. We'd need to see where you rewrote the 8 as 2 to the 3rd. Over here, we'd need to see that you rewrote the 16 as 4 to the 2nd. But once you get it all written to where you have the same base, you could go directly to the answer if you're feeling comfortable with that. So here's a few to try. You might want to pause the video and try it and see how you do. But if you're still struggling a little bit, you might want to go ahead and do it with me. The problem says rewrite the following expressions. Now this is important terminology to know. Simplified exponential form. And I put, see number 8 above. No support is needed, but you may show it if you feel better doing it that way. So these are already all have the same base. So I may just go directly to 2 to the 7th. I'm just going to write down here for note purposes why. That's because we have 2 to the 3rd. If we add the powers together, because that's how many times it would all be written out. So another way to approach the problem is you might write it all out like this. So there's my 6, here's my 6 to the 3rd, and so it's easy to see there that I've got 6 multiplied by itself 4 times. But again, you could just go directly here. I suggest you try to use the shortcut because it really is nice, unless it just doesn't make sense. So you've got 1 5 here, then 2 more, and then 3 more. So you've got 5 to the 6th. Now notice we're not trying to figure out what 5 to the 6th power is. That's because the directions say simplified exponential form. If it said evaluate, that would be different. Have fun with your homework and be very specific and very clear in how you write your exponents. See you in the next video.